Okay, note card 11 is on instantaneous rate of change, and that's going to be what we were referring to as IROC, instantaneous rate of change. And number one, we're given our IROC, or the derivative of a function, at a given value of a. And this is from our last video where we saw x is equal to a. We can interchange those values when we're given a particular value, like in number 1 here x is equal to 2, so that means that we need to find our derivative and substitute in the value of 2. So here again we see this form, and then we also see this other form over here. And both of these mean the instantaneous rate of change of a function at x equals a. Number 2, f prime of a is the slope of the tangent line to f at the point x equals a, or at the x value. And you can go through and read number 3. So number 1, what is the instantaneous rate of change at x equals 2 of the function f given by, and notice we have this f of x value here. So since we've talked about the power rule, we should be able to go through and rewrite some parts of this function and then find the derivative. So f of x, and I do need to rewrite some parts of this, is equal to, we have negative x cubed plus, now 3 over 5x squared, that's really 3/5 x to the negative 2, and then minus 4x. So now that we have all this rewritten, we can go through and apply our power rule. So f prime of x is going to be, and we're going to move our 3 down, so we have 3 times negative x to the 3 minus 1 plus, and then we're going to multiply by our negative 2. So I'm going to have negative 2 times 3 over 5 x to the negative 2 minus 1, and then minus, and then here our exponent is 1 times 4x to the 1 minus 1. So there's the power rule written out for us. So if we simplify this, notice that f prime of x would equal negative 3x squared. And here we should end up with a negative 6 over 5x to the negative 3. So that means that this x has to go to the denominator. And then minus 4 times x to the 0 power, which is just 4. So here's our f prime. This is our slope generator. Now I want to find the instantaneous rate of change, the IROC, which is again the slope of the tangent line, at x equals 2. Find that instantaneous rate of change at x equals 2. So what I need to do now is plug in x equals 2. So really I'm finding f prime of 2. And when I plug in and work all of that out, you should have gotten negative 323 all over 20. And again, we're replacing all of these x values with a 2, and then that's going to give us this value. Now what we've found is the slope of my tangent line at x equals 2 is a negative 323 over 20. Okay, number 2. First thing here, at time t seconds after it is thrown up in the air, the position of an orange is given by, and notice we have this function here, and this is a position function find s prime of 4 and interpret the meaning of the value that you found. So the first thing we need to do is find what does s prime of t look like? What does that derivative look like? And that's going to be our power rule again. So I'm going to have 2 times negative 4.9 t to the 2 minus 1 plus 1 times 25 t to the 1 minus 1, and then plus 3. Remember that is going to be a 0 times 3t. Up here there was no t there, so it's going to be that 0. So remember, all of that is removed, and so we don't even have to think about that. The derivative of that constant is just 0. So we can go ahead and just put in 0 here. Now simplifying this, that tells me that s prime of t is going to be equal to, and once we simplify that, we have negative 9.8 t plus 25. So here we've taken our position function and we've found the derivative of that position function, and that is going to give us our velocity, and that's going to be something we will be going into pretty soon. So here's s prime of t. Now I need to find s prime of 4. So I need to know what is the velocity at this particular time 4. So I'm going to substitute in 4 in place of t, so I have negative 9.8 times 4 plus 25. And when I work this out, s prime of 4, it looks like I got negative 14.2. And this is all talking about time, so, and this was a rate. So let's see, it should be feet per second. Now interpret the meaning of this. So what does this mean, what we've found here? Well, keep in mind that s prime of 4 means that at 4 seconds, the orange is falling at a rate of, and notice since we know this is falling, here we have our negative, so it's falling at a rate of 14.2 feet per second. So that would be interpreting our answers here. Alright, the next one, and notice this is asterisk, so this was from an AP exam. If f is differentiable function, then f prime of a is given by which of the following? So this is the derivative or a derivative of f at x equals a, or here notice we're talking about the derivative, or we're talking about IROC at x equals a. All of that means the same thing. So remember, this is where we changed our x. This is where x is equal to a. So looking at this, the first thing we probably would notice is this part. This looks like our difference quotient, but remember, with our difference quotient we had h approaching 0 because we had to have the distance between our 2 points on the secant line. We had to have that distance between those zeros so that the secant line became a tangent line. So 3 is not going to work for us. If we look at 1, well, this one, notice x was replaced with a, and we have h approaching 0, so 1 works. And notice how our answer choices are written. So we may have, let's see, we've eliminated 3. So we know it's not D and we know it's not E. We need to check 2 because this has 1 and 2 only. So notice we have our f of x minus f of a over x minus a. That portion is correct as x approaches a. So let's go back up and recall what we were given here. And notice the very first part of this, we were told that the limit as x approaches a. This was another way to find our instantaneous rate of change at x equals a at a specific value. So it looks like number 2 would also be an answer choice, a correct answer choice. So from here, I believe answer choice C would be correct.